Welcome back to Geometry, Measurement, and Probability. This is the second half of section 9.1, so let's get started. We begin by talking about mutually exclusive events. Now, mutually exclusive means that our events do not overlap. So let's look at our spinner. For this particular spinner, our sample space is the whole numbers from 0 to 9. We write our sample space with a capital S, and we list those numbers in the funny braces, or the wavy braces, depending on how you look at it, because those wavy braces denote a set. Now, let's suppose A is the event of spinning 0, 1, 2, 3, 4, and B is the event of spinning a 5 or a 7. If all of our outcomes are equally likely, the probability of A would be 5, because there are 5 numbers in A, out of 10 numbers total on the spinner. So 5 out of 10 simplifies to 1/2. Now the probability of B, there are 2 numbers in B, so 2 out of 10 total numbers gives us 1/5 when we simplify our fraction. Notice that these two events do not overlap, and so we can add our two probabilities together. The probability of A was 5 out of 10. The probability of B was 2 out of 10. Add these together, gives us a probability of 7 out of 10. Now again, notice that these two had nothing in common. There was no overlap between our two events. This leads us to our next theorem. When we have disjoint events, disjoint means that they have no outcomes in common. Another way of saying disjoint is mutually exclusive events. With mutually exclusive events and finding probability, all we have to do is add the probabilities together. So look at example 3. Let's find the probability that a card is an ace, and we're looking at a standard deck of cards. Now notice there are 52 cards. There are 4 suits, hearts, spades, diamonds, and clubs. And each suit has numbers 2 through 10. It has 3 face cards, Jack, Queen, and King, and then each one has an ace. So we have 4 aces. Out of 52 total cards, gives us a probability of 1/13 when we simplify our fraction. Now let's suppose I want to find the probability that a card is an ace or a queen. With or, I'm going to be adding probabilities, but I need to think about, do my two groups overlap? No, they do not. And so I just simply add the probabilities. The probability of an ace was 4 out of 52, plus, now notice there are also 4 queens, and the probability of a queen then would be 4 out of 52. Add these together gives us 8 out of 52, which simplifies to 2 out of 13. Now, events that have nothing in common are called mutually exclusive. Earlier, we looked at the spinner, and we had event A was the numbers 0, 1, 2, 3, 4. Event B was the numbers 5 and 7. There are no outcomes in common between these two events, and so these are considered mutually exclusive. You'll notice in the Venn diagram in figure B that these two loops do not overlap. So again, if our events are mutually exclusive, we can just add their probabilities together. Now notice U in the middle. This is called the union of sets, and the union represents an OR. Now let's look at complementary events. So when I think about complementary events, I can write the complement of A as an A with a line over it. So let's suppose that I'm tossing a standard die. My sample space for my die would be 1, 2, 3, 4, 5, 6. Now, if A is the event of rolling a 2 or a 4, the complement of A, I think about not A, so everything in my sample space that is not in A. Not A, or the complement of A, would be 1, 3, 5, 6. The probability of A, there are 2 numbers in A out of 6 total numbers, which simplifies to 1/3. The probability of the complement of A, There are 4 numbers in the complement divided by 6 numbers total in the sample space. 4 out of 6 simplifies to 2/3. When I add these two probabilities together, 1/3 plus 2/3 is 3/3, which gives me 1. Now this leads us to our next theorem. The probability of not A is 1 minus the probability of A. Or sometimes you might see it written this way. The probability of A is 1 minus the probability of not A. Look at example 4. Let's suppose we have a bag of marbles and we draw a marble from the bag. All of our marbles are equally likely to be drawn. I want to find some probabilities. So first, what I want to think about is how many total marbles are in the bag. 6 blue plus 2 red plus 5 green plus 3 yellow is 16 total marbles. Notice in part A, I'm looking for not blue. So if we think about our theorem, the probability of not blue would be 1 minus the probability of blue. So I'd say 1 minus. There are 6 blue marbles out of 16 total marbles. Find a common denominator, which would be 16. 1 becomes 16 over 16, and then subtract 6 out of 16. Gives us 10 out of 16. Simplify your fraction, and we get a probability of 5/8. Now notice again that I use the equal to sign to show things that are numerically equal. Never use an equal just to show different steps. Always remember that everything on the left side, the right side, or between equal signs has to have the same numerical value to use an equal sign. Now look at part B, the probability of not yellow. So this would be 1 minus. There are 3 yellows out of 16 total. Again, our common denominator would be 16, and 1 is 16 over 16. When we subtract, we get 13 out of 16 for our probability. We talked about mutually exclusive events, but what about events that are not mutually exclusive? So we have another spinner. Let's suppose that E is the event of spinning an even number. So on my spinner, I have 2, 14, and 18. Let's let T be the event of spinning a multiple of 3. So on my spinner, the multiples of 3 are 3, 9, 18, and 21. Now notice that these two events are not mutually exclusive. They have an outcome in common. So let's think about first E or T. Well, from E, I have the numbers 2, 14, and 18. From T, I have the numbers 3 and 9. I don't want to list 18 again, and then 21. So there are 6 numbers in E or T divided by 8 numbers total gives us a probability of 3/4. Now, when we have events that are not mutually exclusive, we have a new formula that we use. Notice that we subtract out what's in both. We talked about the union, and the union means or. With the both, that's called the intersect, and you might think about both or what's in common, or think about and for this. Let's go back to our deck of cards. And let's suppose I draw a card at random and I want to know the probability that I have an ace or a heart. There's an overlap between these two events. There's at least one card that is both an ace and a heart. So I have to use my new formula. The probability of an ace or a heart, again, that U is a union, is the probability of an ace plus the probability of a heart minus the probability of A intersect H, or A and H are both. So there are 4 aces out of 52. Plus, notice there are 13 hearts out of 52. And there's only one card that is both an ace and a heart. We already have a common denominator, so subtract your numerators. We get 16 out of 52, which simplifies to 4 out of 13. What if I want to know the probability that a card is a face card or a red card? Again, these have an overlap, so I'll have to use my new formula. The probability of a face card or red is the probability of a face card plus the probability of red minus the probability of both. There are 12 face cards out of 52 cards. Now notice there are 26 red cards out of 52 cards. And there are 6 cards that are both a face card and a red card. Find a common denominator. 52 we already have. Add and subtract the numerators gives us 32 on top, 52 in the denominator. Simplify your fraction is 8 out of 13. On the top of the next page in your notes, you have a summary of probabilities. We talked about the probability of 0 is an impossible event. A probability of 1 is a certain event. Our probabilities are always between 0 and 1 inclusive. If our events are mutually exclusive, we can add the probabilities. And if they're not, we have the new formula in number 5. And then we also have our probability of the complement. So the probability of not A is 1 minus the probability of A. Now, by the way, in number 6, make sure you make that correction in your notes. There should be a line over that A. Let's suppose I have a golf bag that has 2 red tees, 4 blue tees, and 5 white tees, and I want to find some probabilities. First, I need to know how many total tees there are. So there are a total of 11 tees. In part A, we want to know the probability that the tee is red. There are 2 red tees out of 11 total, and our fraction doesn't simplify, and so the probability of red is 2 out of 11. Part B, what is the probability of not red? Remember our formula for not. We have 1 minus, and then the probability of red was 2 out of 11. Find your common denominator, which would be 11, and 1 becomes 11 over 11. Subtract your numerators, and we get 9 over 11 for our probability. In part C, we're finding the probability of red or blue. There is no overlap between these 2 events, so I can add the 2 probabilities together. The probability of red is 2 out of 11. The probability of blue is 4 out of 11. Gives me a total of 6 out of 11. Look at example 7. This bag contains marbles, and we draw a marble from the bag, and we're going to suppose we had the same chance of drawing any marble from the bag. I want to find first the probability that a marble is green. Figure out how many total marbles you have. We have a total of 25 marbles. There are 7 green marbles out of 25 total marbles. Gives us a probability of 7 out of 25. In part B, we're finding the probability that a marble is not red. So for the not, we can say 1 minus. There are 8 red marbles out of 25 total. Find your common denominator of 25, and 1 becomes 25 over 25, and subtract, and we get 17 out of 25. And last, let's find the probability that a marble is blue or yellow. These 2 categories do not overlap, so I can add the probabilities. The probability of blue is 4 out of 25, and the probability of yellow is 6 out of 25. When we add, we get 10 out of 25, which simplifies to 2/5.